Let's talk about some explicit exponential examples. Starting in the year 2006, the number of speeding tickets issued each year in Middletown is predicted to grow according to the exponential growth model of the form P sub n equals P sub 0 times 1 plus r to the n. Now this formula will be given on the exam. It's nice that it's in the problem, but you don't need to memorize it. All right, during the year 2006, Middletown issued 220 speeding tickets. All right, so this is our initial information. So that's going to be two things. First off, P sub 0 equals 220. And also, we know that T equals 0, not T, sorry, N. N equals 0 is 2006. All right. Now, every year thereafter, the number of speeding tickets issued is predicted to grow by 5%. Now, when you're given a percentage for growth, that's exponential. Linear growth is a constant increase-decrease. Exponential is a relative or a percent or double or triple or half type of increase-decrease. So because it's exponential, we can work with our exponential rule, which again was provided. And R, we have as 5%, and we know that percent means divide by 100. So we have 0.05 for R. So we can now write our explicit model. P sub 0 is 220. R, 1 plus R would be 1 plus 0.05 to the n. You could simplify the inside if you wanted to write that 1.05. That's okay as well. But ultimately, if this trend continues, how many speeding tickets are predicted to be issued in 2019? Now, if we take 2019 and we subtract the year that corresponded with our 220, we get, that is 13. This kind of stuff, that's scary if that's not 13, but my brain is not wanting to produce things quickly. So 13, we want to work out P of 13 for this. And that would just be, we have our explicit model, so it's 220 times 1.05 to the 13. And this is something we can easily calculate with our calculator. $414.84. Now we look and see what type of rounding we want. It says round to the nearest ticket. So it doesn't say round up or round down. So we want to do regular math rounding. So 414.84, we would go to the 0.8, the 414.8, and that would round up to 415. And now for our story problem answer, 415 what? 415 tickets. Okay, next up, write the recursive model for the number of speeding tickets. Now the recursive model, we have to give P sub 0, and then we have P sub n equals P sub n minus 1 times 1 plus r. Now this 1 plus r, we've already simplified all the way down to 1.05. So we can say P sub 0 equals 220 tickets, and P sub n equals P sub n minus 1, parenthesis 1.05. and then we can say n is the number of years after, and this all started in 2006. So if we provided that information, they would know 220 is from 2006 and how to find anything after that with the recursive model. All right, now it's your turn. See what you come up with. So pause the video and work this out, and I'll be right back. What you should have, P sub n equals 7.6 times 1.02 to the n, and P sub 7 equals 8.7 billion. And the recursive model would be P sub 0 equals 7.6 billion. P sub n equals P sub n minus 1 times 1.02. And again, P in billions, and n equals the number of years after 2018. All right, hope you got it.